So let's continue making Ghosts and Goblins in Unity. And today, I'll be working on the ladder state. But before that, need to work with the inputs. The way I'm dealing with the inputs, I'm gonna create the C# class and also an input definition class that I'll be using on all states. So let's start creating the input definition. And here we got the class, but before that, let's create the C# class. So here we got the input action, generate C# class, player input actions, Lebanon space, generate. All right, now we can wait the reload, go back to the input definition. And here we need the input action, but we need to use the namespace for that. So let's create the input action, use engine dot input system dot input action. All right, this will not be mono behavior. Let's also change the namespace. All right, so now we can create the private input action, input action. And this action will be the action that this class will be responsible for controlling. And we'll be creating two input definition class. One will be for inputs that don't need to read any value, and the other input definition class will be the same thing, but you can read value from the input. So we can create the input value type, the generic, and where t is equals to struct. So this way we can read like floats, vectors, ints, whatever value is a struct. Then we can create the public bow was preset this frame, and then we can return the action dot was preset this frame. And we can also make this read only. We can also create another bool is preset that will return the input action is preset. Also the value from this input. So we can create the t input value type, input value that will return the input action, read value type, input value type. All right. Then we got the constructor, the input definition that will require an input action that this class will be responsible. And then we can just set here the input action. Also enable the input action. Alright, so this is the input definition class that can read value, but we can also create another build class, input definition, that will be the same thing, but it will not contain the input value. Alright, that's what we need. Alright, so this is the input definition class. Now we can go to the input controller. Let's search here. The input controller. Here we can remove this and use the layer input actions. Then we can create the input action. Alright, so here we'll be creating properties for the input definition. So the first one will be the jump input definition, jump input, private set, and here the jump input equals to a new input definition using the player input actions dot jump, and can create a method for that. Their inputs. All right, and then we can do the same thing here, but using float for the movement input, and create a new input definition. Right, and we can remove this require component. Now we need to fix these errors that appeared here on the console because of the states and the transitions. So let's change this. You can just remove this and use the f dot approximately the inputs controller, move input value close to 0. Alright, we also don't need the rigid body and remove this. Alright, this as well. The next one is this is trying to move. You can use the move input dot input value is not equals to 0. And here on the player's trying to jump, you can use the input definition to create a reference to the jump input. And here we can just check if this was pressed at this frame. The input was pressed at this frame. Alright. Then we can return. And it will be the same thing on the rotation. Need the movement input value. Alright. And here on the movement state, we can create a new vector too. That will be the movement value, input value. Can remove this. And on the y-axis will be the player body.velocity.y. We don't want to change that on the movement state, so you can just keep like that. Alright, so also let me move this to the final, okay. And the errors was fixed. Now we can remove this input and check if it's working. Press play. Alright, cool. I just don't like the way the jump gravity is working. I need to increase the value. So I'll put a value of 4. Press play again. I guess this is good. And for the jump, I guess the value of the jump height of 1.4 is good. And yeah, that is okay. All right, so now we need to import the event bus system uh, that I made on the previous video. So, right, so I just imported the event bus and the global logger, the two events that I created. The player finished climbing ladder and the player start climbing ladder. That's that's all we need to create the ladder state using these events. They communicate between the player climb ladder state and the ladder controller that we also need to create. But first, I'll create the player player climbing ladder state. All right, let's move this namespace to the state machine of player state base. Let's implement the abstract class, and I will first start on the using statement. So the first using that we need is the player inputs controller that is inside the game entities player inputs controller. Then we need the entity component reference that we will be using to reference all the components that we need to make this state work. So let's paste right here. And we also need a reference to the player rotation controller because once we enter this state, we will be disabling the rotation so that the player can't rotate uh, once he's still on the ladder. Also be using the system type. You'll be using the two events of the event bus system. So let's paste right here. And we'll also be using the event system and the UNC engine namespace. All right. So for now, that's all we need. We also need the ladder controller, but later we'll be creating that class later. All right, so let's start creating the fields that we need. The first one will be a layer mask. What layer is ladder so that we can check. We also need another layer mask about what layer is ground. Then we need a float of climbing animation speed because we'll be controlling the animation speed of the player uh, once he start climbing. We also need the climb speed. This will not be about the animation, but the velocity of the player on the movement. Climb speed, actually. Climb speed. This one is important. The animation adjustment that amount. Uh, we'll be controlling the animation uh, time here via code. So that way we can control the final climb steps of the player. And also on the movement, it will make more sense once we implement that. And I'll also show on the animator panel. Then we need the animator of the player animator. We also need the collider, player collider. We also need the input, player input controller. and the rotation, player rotation controller. And here we will be also creating another float of the default gravity scale, because once we enter this state, we will set the player rigid body gravity scale to 0, and once we exit this state, we need to set the default gravity scale again. That's why we'll be caching the gravity. Creating another float, the default climb animation time progress. The time progress of the default animation, because the ladder state uh, has 3 animation states. The default one, uh, like he's the middle of the ladder, and he's climbing, and once he climbs to the top, he'll be switching the state to the animation state to the climbing final 1 and 2, and this one will be the default time progress, so that we can control each animation time progress. This one is for the default, but we also need the climb time progress for the other animations as well. So here's the progress of the 2 animations, and I also just created 4 constant uh, fields here. The first one is a climb ladder animation layer. Uh, is set to 0 because the layer that will be working on the player animator is 0. So this is the layer that we'll be working on. And this is the default animation desired length is set to 1. Will be always be increasing the length of the time of the animation. This is the inverse because maybe you are on the top of the ladder and then you start the inverse animation. And then we got the inverse animation stat multiplier that set to -1. That is to make the step amount adjustment to go inverse. Then here we got the states that we'll be working on: the climb ladder, the default animation, the final 1, 2, and the standing idle that will be set once we exit the ladder. Now we can set up the state, getting the player animator. The player collider, and I forgot to say, but we also need the player rigid body, so I just created this field here. And here's the state setup, just caching the components. Then we can override the enter state. And the first thing that I'm gonna do is disable the rotation and cache the the gravity scale. Now I need to adjust the player's body, set the values that I want. So I'll create just player first body, and here I'll set the gravity scale to 0 and set the velocity to 0 as well. And I'll also move this default gravity scale here and call the method once we enter the state. Now we need to reset the animation values. Set animation values. These animation right here, the time progress. Just set to 0 because once we enter the state again, this will be resetted. So reset this. And now let's implement the I event invoker and implement the interface. here you can just call the event bus, invoke, event type this, and the event arc. And once we enter the state, we can just invoke the event of type player start climbing ladder. And here, instead of creating an event arc, you can just set the default value to null. Alright, let's set this to null as well. Alright, so that's what we need first to set up the state. Now we need to create the ladder controller. So let's create right here. I'll create the folder later, but right now let's create the ladder controller. And the first thing that we need is the ground, the ladder ground. So let's create the field, serialized field, public object ladder ground object. Right. Then we need three positions. The first one will be the exit top, the start bottom, and start top. The ladder exit top position will be once we uh, climb the ladder and reach the top, we'll be exit and set the player to this position. And this one, these two positions just to set once we enter the state, we can check if we are at the bottom or at the top and set the position of the player accordingly. Then we need enum right here, ladder state that be being climbed and not being climbed, and the current ladder state. So that way we can control the current ladder state. Also need a tag for the player tag that we'll be using on the physics events, like on trigger, exit, enter, and stay. And then we need three And then we need these fields to control the exit offset of the top. This is a const value because this is the best value that I found that works for any height of ladder, 0.93f. You can adjust that, but I think that's good. And this index here is to get the points of the edge collider. We'll be using edge collider on the ladder to uh, get the start bottom and top position. And this is the index of the bottom and top. And here on the awake, the exit top position will be our position plus our transform.up. And here's the offset that I think the value is good. We multiply the transform.up by the exit offset. That way we will not be the error once we exit the state. Will be like on the same position of the ground game object. Now we need to set up the ladder start positions. Let's create this right here. And first we need to get the edge collider. We can also make this a our component. Right. And this is what we need. We need to get the ladder edge collider, the point on the bottom and top index, and then transform this point using our transform.transform point that will transform from local position to word space, so that way you can set the player position to the same position that is the ladder point. And then we just cache these positions. And this is on the awake. Then we got the on trigger state that we just check if the collision that we are currently triggering is the player. If it's not, we just return. Else, we check if the player Y position is greater or equals to the ground game object position, and the current ladder is not being climbed. So, like we are running above the ladder, then we just set the ground game object to true because we're not climbing. We got the on trigger enter and exit that we check if the player that we are triggering. If it is, then we need to subscribe to the event that the player is invoking right here. And to do that, we need to implement the I event listener interface. Let's implement this and subscribe to events once the player enter the ladder trigger and subscribe once he left. Alright. Here on these events, we want to subscribe to the player start climbing and finish it uh, and call these methods. So let's create them. So these methods is very simple. We just check uh, once we once the player start climbing the ladder, we set the ground game object to false and the current ladder state to being climbed. And once he finished climbing the ladder, we just set the ground game object to true and the current ladder state to not being climbed. Alright, that's why I check if the current ladder state is not being climbed to set the ground game object to true. And yeah, that's all we need to the ladder controller. Now we can go back to the climb ladder state on the player. Okay, here. So let's create a current ladder inside the player climb ladder state that will be caching once we enter the state. And to get the ladder, we just use the overlap box in our position, the player collider size, what layer is ladder, and once we get the ladder trigger, once we overlap with this trigger, we just get the ladder controller component and cache inside the current ladder field. Alright, now we need to adjust the player on the ladder. Let's call this method right here that we'll be using to check if we are on the bottom or at the top of the ladder and adjust the player there. So let's first create a pool. Player is at the bottom the ladder. This will simply return our player body.position.y less or equals to the current ladder dot position.y. Now we check if player is at the bottom of the ladder. Let's also return here. Then we'll set the player's body position to the start bottom position. Else we'll set to the start top position. Now let's create a method here, call it private void play animation that will be using the animation state hash and normalized time that for default is set to 0. And here you can use the player animator play. The animation state hash is the layer animation that we set and the normalized time. Now we can use this method to play the default animation. There, climb ladder using the default animation time progress. We'll be playing the final animation, so that is the inverse because we start at the top here. And we also need to set the animation time progress of the animation 1 2 to 1, because since we are reversing the path of the ladder, we need to set this to 1. So then once we climb to the bottom, we'll be decreasing this value. And once we adjust the player, and that is adjusted the player on ladder. Alright, so now we need to update the animations, but before that, we need to get the ladder input from the player inputs controller. So let's create that. So here, I'll create a ladder input. That would be the type of axis, positive, negative, um, WS, right? Now we go into the player inputs controller and create a new input definition. Ladder. So now we can create the update function. And let's create a new update climbing animation method. And here we check if the player ladder input press it is false. If we're not holding any key from the ladder input, we're not moving or something, then just return. Now we need to create a helper function here. O player has reached top point, that will simply return the player visual position if it's greater or equals to the ladder, current ladder, start top position, Y, right? And we also need to create a pool is allow it to move. And inside here, we will return the current animation. So let's create the hash. It will be the player animator dot get current animation state info on the layer, climb ladder animation layer, short name hash. Let's rename this to the current animation short hash. And we return the current animation. The current animation playing is not equals to the final player climb ladder final animation state, and the final top exit animation progress 1, the first state, is less or equals to the inverse animation desired length. That means we can only move uh, if we uh, we're not playing the final second animation state from the dot climb, and if we are doing the inverse path, we need to wait the current animation progress is less or equals to the inverse animation desired length. That means that once we switch from the top climb animation to the default one, then we can move. Right? Now we can check if player has reached top point. Is false, and is allow it to move like we are in the middle of the ladder. Then we can create the handle default climb animation. Let's create here. Now we need to check the current animation progress to, like, if we reach the length, then we just reset. But this function will just increment and turn the current animation progress. So let's create a private who is next animation step progress uh, greater than desired length. And here we need to get the current animation time progress, desired progress length. And this is what we need. The reason why I'm using half uh, for reference keyword on this float is because I need to return a bool and also change the float. I mean, I can change that later, but for now, just keep the reference parameter. So before we implement this method, we also need another method that we well adjusting and clamp animation progress. And here we don't need the ref parameter, so let's create just a float uh, around float step amount, and let's change this step. Here let's create an int multiplier that the default value will be 1. So here you can increment the parameter by the step amount times the delta time and the animation speed by the multiplier. Here let's clamp the value parameter 0 and 1, and we turn the parameter. Now the current animation time progress will be just a clamp animation step using the current animation progress, the animation adjustment step amount, and the multiplier we don't need to change. So let's return the current animation time progress greater or equals to the desired progress length. Now we can check the if next animation time progress using the, let's get the default live animation time progress and the default animation desired length. Passing as a reference parameter. Then we can just reset the time progress. And after that, we just need to play the animation using the default climb animation state and the default climbing animation time progress. Alright, this is the handle default climb animation method. After that, we just return, else, check if player on the ladder input is greater than 0. Then we call the handle top climb animation. Let's create right here. Now we check if next animation time progress greater than desired length using the progress 1 and the default animation desired length. If it's false, we didn't finish the progress yet, then we play the animation 1 using the final climb top exit animation progress 1 as well. Then we return. Because on the top climb animation we have two states, and this is the first one. And after we finish this, after the progress is greater than the target length, we check again if next animation greater than length using the final progress 2 and the default is false as a ref parameter. Then we just play the second animation state using its values. And this is the handle top climb animation. And here we also return. Else we just call the handle verse top climb animation. That's great right over here. And since we are doing the inverse, we need to also check the inverse progress. So that's less than and inverse. And here, this will be the same thing, the same parameters, and here will be less or equals to. And here we'll be using the inverse step multiplier. All right. This is the parameter that we created. It's just a negative one. All right. Let's go back here. Now I will copy this code, paste here using the inverse method. Switching this states. Inverse desired length. And here we just change the animation states. All right. If we start from the top, we'll be using this method right here. We'll start by the second state, go to the first one, and then go to the default animation. All right. That's the first stop climb animation method. Now we check if player has reached the top point and the top progress to greater or equals to the desired default length. Then we will just finish climbing. We'll just call this method right here. And here we will just play the idle animation. We'll set the player where's the body sort of position. I will explain this, but for now let's set to the current ladder exit top position, and then invoke the player should climb ladder event. The reason why I'm using transform that position instead of the rigid body position is that if you set the rigid body position, uh, the position will be only updated on the next fixed update call. And that may cause your player uh, some weird hinder effect that like playing the idle animation while standing on the top exit position. That's why we set the transform dot position that gets updated immediately. Right here. This is the finish climbing method. Now, I guess we just need to call the fixed update function and move the player uh, on the ladder. And here we just check if this allow it to move. Then we just call the move player on ladder. This method right here. And here we will first check if the player ladder input is greater than 0 and player has reached top point is false, like we're trying to move up. Let's return. And here let's check if the input value is less than 0. Let's remove this return. Alright, so now we need to move the rigid body position towards the target position. And so let's use the rigid body position equals to vector 3 dot move towards rigid body dot position, and here using the same position plus vector 3 dot up, vector 2 actually. For the max distance delta, we'll be using the climbing speed times fixed delta time. And the same thing here, but vector 2 dot down. Alright, so now once we exit the state, we'll get the rigid body scale and set to default and get the rotation and enable again. Yeah, that's it. I will create the state forgot to create a submenu. Let's create here. Climbing ladder state. Okay. But now we also need to create the transition to this state. Alright, so here I create a transition, call it can player climb ladder. Or to this namespace. So first we need to create a layer mask. Let's get it using this engine. What layer is ladder? Next, we need to get the player collider and create read-only array of collider overlap its results of using overlap box. And we also need a player inputs controller. So let's get all these inputs. Alright, so first we need to check if the player controller ladder input plus press this frame is false. Then we just return false. Alright. Else we will be using array.clear. Overlap rates hits results 0 and the length. And then make a overlap box right here. Overlap box on unlock using the player collider on center. Player box collider size. We don't want any angle, and using caching the inside the overlap its results array. Then we check if overlap its result inside the first index is no. Then we return false as well. If player controller ladder input LA is greater than 0.5, the player start position y is greater or equals to the overlap its result. Transform position.y, we return false. This means that if we are at the top of the ladder and we press the W key to climb to top, we don't go to the ladder state because we can't climb anything because we are already at the top. And else we do the same thing here, but using the inverse condition. All right. Else we return true. All right, so let's create the transition and create the ladder layer. Right here. Okay. So let's create a test ladder. So let's create the ladder. Here. And we also need to create the ground object that will contain an edge collider. Move up here. Edit the points. Guess it's kind of hard to see. Right. I mean, they don't need to be that long. Yes, this is good. All right. This will be the ladder ground. Then we need another edge collider. Will be a trigger. And set right over here. Guess like 5 maybe. Let's test like this. Now on the climb ladder state, the ladder ground. Here let's put a value of 10, 4.5 I guess. And adjust here on the idle state. Now let's just put on the idle to the climb. If player climb ladder and is ground. From the climb ladder state to the idle if is ground. Alright. Alright, so after creating the ladder edge trigger, let's add the ladder controller and assign the ground game object. And now we need to create the animation from the to the three states. Alright, so I just created the animations and it looks like this. The climb ladder, the default animation, final one, and it's right here. they're not in the loop time, and the speed is set to 0. So I'll just set it right over here, and I'll press play. So as you can see, it looks like this, the animator panel. But you can see that this animation right here, it looks like it contains an offset from the out from the other sprites. So we need to change that. So pause the game, go into the art, right here. Let's use the custom pivot. Let's set maybe this value, uh this one right here. Let's test like this. Uh I mean, the height is good, but now it's to the right. Let's adjust this right over here. Let's play again. A little bit to the right. Let's try again. Right now it looks good. You can see that if we look to the left and climb the ladder, we'll still be looking to the left and we can't rotate while we still on the ladder state. Alright. We can't go to the ladder state while jumping because it's all set right here. And this is how the animator works here. And the sprite library. You can see it changing here. And once we got to the top, let's switch to this state. And this another one to finally finish the climbing. So yeah, that's it. This is the ladder state. And I guess for to the next part, I'll be setting all the parameters in one place right here. So that's for the next part. But now we got one more behavior state. and it looks good. Yeah, that's it, and I see you in the next part.